All right, so hello and welcome. On to the next question. We'll keep going. Take a few seconds to make sure the audio is working. This is going to be... All right, so hello and welcome. On to the next out the chat already. This is going to be remove zero-sum consecutive... Actually, I don't know what the whole question is. Remove zero-sum consecutive nodes from linked list. Okay, let's see how this one goes. Given the head of a linked list, we repeatedly delete consecutive sequences of nodes that sum to 0 until there are no such sequences. After doing so, return the head of the final linked list. You may return any such answer. Note that in the examples below, all sequences are serializations of list node objects. Okay, so head 1, 2, negative 3. So this sequence adds to 0. We should delete it. This does not. Answer 1, 2, 1 would also be accepted. This one also could be accepted. Okay. Any such answer? I think this is a little confusing exactly how this should work. But you could do this using just a double for loop. Negative 1,000 to 1,000. Okay, I'm not really sure I understand. I don't know about this one. 1,000 nodes. I think quadratic time algorithm is the easiest. You just want to start from a particular node and then move to the right to see if if this sum ever goes to 0, and then you can delete that section. But if it doesn't, then you go to the next node. I think you just do a quadratic time is the way to go. There may be a way that's a little bit faster, but I'm not going to spend too much time trying to figure that out. Because what could happen is, like, let's say this doesn't go to 0 at any point, then you can't like just stop the whole thing, right? If this was like a 2, yeah, you can't. The really simple linear approach with a sliding window, the really naive way of doing it, I don't think works properly the way that I would like it to. But you could just do one at a time. That's fine too. Yeah, quadratic time is fine. We'll do that. Let's do that. So, while, let's say, we'll do the first one. The first one's special, actually. So we'll say list node head. Well, yeah. Okay, let's return head. Okay, so I'm going to reuse this variable here, and I'm going to say I'm going to use one for loop, and then use a double for loop after that. First for loop is just going to be say n. Node is head next. While node equals node next. And I have a sum prefix starts off at 0, and say prefix plus equals maybe it starts off at head actually. Node value, right? If prefix equals 0, then I want to perform this modification, right? And I'm going to say we're going to create a new head, and we're going to break. So break, and I'm going to say head is going to be equal to a little bit more complicated thing going on here. So I've got this node pointer. This should point to the next value, right? So I get a bunch of things added together, and they add to 0. I'm going to delete all that. I'm going to move the head node or across to the next node. I'm going to say node next is a null pointer, right? And I'm going to delete previous head. So I'm going to set the yeah, so there's some things involved here. So I'm going to save the previous head. I'm going to update the head to the node next. I'm going to take the node next, set it to next to a null pointer. I'm going to delete the previous head, and I'm going to set that to a null pointer. Its next value to a null pointer, if it so it's next. No, delete it first. So I'm assuming there's a recursive deletion that's going to happen here. That it's going to free all of its. It actually doesn't have that, so I have to do it like here, which is a little bit tricky with the memory management. Yeah, basically you'd want to delete all of those. Like if these were unique pointers, this would be a little bit easier to manage. But basically, I just want to do for each list node x, set that to node, and then while x is not a null pointer, x equals x next. It's actually, let's do it the other way around. Let's do it like this. List node y equals x next. X next equals null pointer. Delete x is actually going to be the head initially. No. Okay, let's do it this way. Previous head is head. Head is the node next. Then I'm going to start with previous head and delete that whole thing. I'm going to get the next value y. Then I'm going to delete. I'm going to set the x next to a null pointer, and I'm going to delete x. And then I'm going to set x equal to y. Okay, it's a little bit involved, but that should work. Yeah, that will delete from memory the beginning section, and it'll also give me the set the head up to the next value, and it'll stop. It'll break there. Okay. Yeah, kind of involved, quite frankly. This is going to be sort of like the subroutine here. So now, oh no. All right, I have a better idea. No, never mind. That's not going to work. Okay. There's actually some problems here. Sent. Sentinel. Or fake root. Or fake head. F head. That's not good. Let's just say previous head. New list node pointer. Make a unique reference to this. Make unique. Can I do this? I don't use these very often. As you can tell, this might take me a little while. This is a function. This is kind of useful, but I think it has to be sorted, right? Let's make unique. consecutive adjacent duplicates. If you sort first, it'll remove all the duplicates. Yeah. Okay. Make unique is a little more sophisticated. I notice it's different from unique to function. Constructed a non-array type T. Construct an object of type T and wraps it in a unique pointer. Okay. Make unique. Works. Yeah, I think that's what I want. Just make unique. Has no arguments. Okay, I think that works. I may need to this node. So I can see an example. Unique pointer vec3. So the unique pointer is itself the pointer to vec3. In other words, if you make a unique pointer a vec3 pointer, that makes things a little bit more confusing, but that's probably not what you want to do. Probably not what you'd want. Yeah, not what you want to do. All right. Anyway, so I can make unique. Okay. Actually, it doesn't have a deletion operator anyway, so it doesn't really matter if it's unique or not. But I might as well do it this way, just for good practice. Yeah. So this should be this node result is going to be previous head next, and then delete previous head. I think I can get the pointer, right? Hold on. What if you're using unique pointers and the doesn't have a deleter? Default delete? Oh. Unknown deleter is specified. Empty class is untypical. Oh. Does it automatically delete? Undefined behavior. Okay, shared bad. So don't do this. Don't create an int array for shared point events. Oh, okay. You could do it this way though. And the default behavior is not going to be the right delete. Calls delete with the okay. I see. So actually, no, it will call the delete. No, it'll actually work properly here in this case. It'll work properly here in this case. That's cool. Let me hold on to this. Yeah, I kind of need to practice that a little bit more. So actually, no, it will delete appropriately. What I want to return is the results, and I want this previous head next to be a null pointer. Yeah, so I don't have a dangling reference when this gets deleted. Interesting. Okay. This previous head will be deleted because it's a unique pointer. I think that's fine. Anyway, so previous head next is going to be, I think the value is 0 by default. Yeah. Next is going to be head. Okay. All right, so this node current is going to be previous head next. And okay, This is so confusing. It's confusing and becoming even more confusing with my my unique pointers being thrown into the mix. Okay, it's fine. It's okay if I take some time to do this. Yeah, I'm at 15 minutes now. Okay, that'll probably be at least another 15 minutes, I think. All right, so the idea would be I create a sentinel head, right? And the reason I do that is when I want to delete, I can use that previous head and delete everything to the right of that previous head. And I'm going to start at current point, which is going to be the previous head next, right? So go back to the previous head and go to the next value from there. Set the prefix to 0. Take node, which is current, current, and I'm not sure about this part. We'll come back to this. I think actually this should be, each iteration should be previous head next. We'll come back to this, I think. Current, I don't know. Yeah, this is node equals node next. Okay, increment the prefix amount. If the prefix amount is 0, then I'm going to say, I'm going to update the previous head to point to, yeah, when I dereference unique pointer, object owned by this equivalent to get, okay. Pointer to the object owned by this, you get. Okay. Bar, pointer. Unique pointer, foo, pointer, new foo, bar, pointer, bar, f of pointer, f const foo. Okay, I think that makes sense. Yeah, it's supposed to work like a regular pointer, I think. Okay. So I'm going to set my previous head next to. So I want to perform deletions first. I could do this first. I could do the deletions first. This is going to be from current up until node. Update current. And this actually is going to be here, or x rather. X is not equal to node. Oh, so this is confusing, huh? Y is going to be x next. I'm going to say x next is null pointer, delete x, and set x to y. Okay. At some point, x is going to bump into node, which is either empty or it's the last node that I added. So then we're going to actually delete node. We're going to set the previous head next. Is going to be node next. We're going to delete. We're going to say node next is a null pointer, and delete node. And we can break here. Don't set node to the next position. And we go back to current is previous head next. And repeat. So after each deletion, I'm gonna move my head. This isn't correct either. It's so confusing. Okay. Oh no. Excuse me. I need current and previous. That's the issue. Yeah. I don't know if I need this. You do it like this. I think it's fine. Yeah, previous is previous head. Current is the next. Yes, that's what I need to do. And then I need to update. Previous is current, and update current to current next. Okay. I don't know if that makes sense. It doesn't make sense. Node is current. So what gets updated here is not previous head, but just previous. Yeah, that's really confusing. There's too much going on here. It's too much. Mechanically speaking, this is too much. This is too much. It's like, I don't know, it's a good question. Definitely involved. More involved than I thought. Oh, okay. Does that work? Okay, that's what I want. Runtime error. Okay, of course. It's like half expecting that. Okay. Jeez. There's too much going on here. So I create a sentinel value called previous head, and I'm going to use that at the end. The result is going to be the previous head next. And then that's going to be, that previous head is going to be deleted by the unique pointer. And then I'm done. Set the next value of the previous head to the head, and then I have a previous value, previous head, current value, current was really the head, current head. And what I'm going to do is I'm going to iterate while current has a value, and I'm going to have a prefix amount, and I'm going to loop. I'm going to set node to current. I keep looping until either a node goes off the edge, or until node goes off the edge, or I'm going to have another condition here. We'll come back to that in a moment. In an if statement. And I'm going to grab the prefix amount. I'm going to calculate that as I go. And if the prefix amount is 0 after adding the node value, that means I can delete the section starting from current to node inclusive, current and node. All of that can be deleted. So I want the previous value next is going to be set to node next. And then I'm going to set node next to null pointer. And then I'm also going to delete I'm going to set previous next which should be current actually. Oh yeah, that's a little bit confusing. Okay, so So current should be pointing to previous next. I can set this to node next, set this to a null pointer, and then X is still pointing to current. I'm going to go until I get to node, until X is equal to node. This actually doesn't have to happen here. This can happen over here. Oh yeah, that's this part. So delete everything left to right until we get to node. X just goes to so it should be X is going to X next. The problem with doing that though is that I also want to delete X, so I have to get a reference to X next. Actually, we'll just say Y, and then I'm gonna set X next to a null pointer. I'm gonna delete X, and then I'm gonna set X equal to Y. Right. Keep going until we get to node, in which case we stop, and then node next is null pointer. There's another issue here. X is not an end. X and X is not equal to node. Node could be off the edge. Actually, I didn't think about that. No, node is not empty. No, node exists. Node will always exist, so I don't need to check this. Excuse me, don't need to check this. So that'll delete everything in that section. And it's going to set the previous next to node next, and then now at this point we broke, right? So node was deleted. This isn't going to happen because we broke here. We come back up to this part of the loop and we say previous equals current. Okay, something important here. So the previous node is going to be so I'm going to update current here. Right, that's kind of an important part. This. After this, current gets updated to, that's kind of important. What is current pointing to? Current got deleted here. That might be why I have the runtime error here. It's too many variables. This is too complicated. I don't know what I did something weird here, something wrong. Made this more complicated than it needs to be. I should probably look at some of the solutions to this. Think about linked lists a little bit more, how I can make my code a little bit more manageable. Too many variables and too many things going on. X is current. X got deleted. Now current is deleted. What should current be pointing to? Current should be pointing to node next, or current should be pointing to previous next. And the same thing here. Current should be pointing to previous next. And then previous ends up pointing to previous to current, and then current goes to current next. As long as current exists. Previous is always going to exist, or should always exist because of the sentinel value. Does this always happen at the end of this? Yeah, this happens. It doesn't matter if you break. It doesn't matter if you do it there or not, because it's gonna happen here anyway, and this has to happen anyway too. Let's say this doesn't delete anything. That means we went all the way to the edge, without any sums. previous next, and then both of these jump forward. That's a little confusing. There's probably a better way to write this where it's not so confusing. There's like a lot of detail there, a lot of issues going on there, a lot of things. Let's still runtime errors too. Ugh. Okay, maybe I need some linked list practice. Well, this is why I practice, right? It's the reason for practicing. Let's see, where's the runtime error? Why am I getting runtime errors? Why is this happening? Ooh, why? Let me try to find which test case that is too. Whew. Boy. All right, the first test case. So 170, 200, 200, 170, 200. 170, 200, 200, 200. Right? So I should delete these three. Then calls 170 with 200. What's the prefix amount afterwards? Okay, let's try this one. After 200 is called. So here we have prefix 0. Here we have prefix 1, which is what I expect, right? Prefix 0. So we get a 1 here. Why don't I get 3? What is happening? Yeah, I think it's like kind of too complicated. Whatever I did here is more complicated than it should be. It's not supposed to be that complicated too. It's actually supposed to be pretty simple. I think because I have the deletion code in there, which is kind of annoying. Like I would prefer to just delete a particular node, I suppose. Memory management. So yeah, 1, 2, 3 is fine. Then prefix is 0. That all gets deleted. Current is previous next. Actually, previous gets set appropriately after something gets deleted. Excuse me. Let's do it this way. Actually, let's do it this way. Let's set current to previous and then shift them forward. Previous equals current, current goes to current next. That might be more appropriate, actually. I think it's jumping ahead 1 that's not supposed to jump ahead. But this is so confusing. These variables. TLE, of course. No. 3, 1, 4. 3, 1, 3, 1, 3, 1. Why doesn't this jump ahead? Doesn't this jump ahead? Am I crazy? Oh my goodness. I gotta really think about this. A few things to consider, like how could I make this simpler? Number 1. Number 2, like how could I approach a question like this in the future and make it a lot simpler. And 3, how do I fix this? Really gives you a bunch of different questions to ask and think about here. This definitely has quite a bit of room for improvement. Especially the speed. I should be able to do this very fast. I mean, the basic idea is very straightforward. It's just use a sentinel value and then delete the. I guess I didn't fully explain this, what it's supposed to be doing. That could be it, part of it. Delete the section that sums to a 0 inclusive, and then set up the sentinel value to point to, not the sentinel value, no. It could be a sentinel value, but it doesn't have to be. It's just the previous value that it began here. The previous value now has to point to sort of the tail over here. Node next, just the tail, right? Okay. I think I don't use this at all, actually. I just said previous to current. No, this doesn't work properly. This isn't right. Something's wrong here. I gotta think about that a little bit more, about like how do I set up the next variables for the next iteration. So if I get all the way through here, there's 2 things that can happen. One is I don't reach this block. If I don't reach this block, that means that I went all the way to the end, and now I've got to just move previous and current to the right. So previous would then be, so does current get updated anywhere here? No, it doesn't. Current doesn't get touched inside here. Current maybe got deleted, but if I didn't execute this inner block, it didn't get deleted. Then I could just say previous equals current, and then current goes to the next value, and I just shift them both down. That's fine. However, if current is deleted, now I have to set current to wherever previous is now pointing to. Previous next. So can I just set current to previous next? Why can't I just do this? That's what I did last time, right? So we delete a bunch of stuff. Previous next is now pointing to some new node. The current node now should be that previous next node. And actually I should continue from that point. Okay. So that's confusing. Yeah, depending on whether or not I reach this if statement, there's different things that I can do. Like what the nodes are pointing to changes. It's like not consistent depending on the branch. I think that's what I'm struggling with. What current and previous are pointing to. What current and previous are pointing to is they don't change if I don't reach this if statement. Previous doesn't change ever in both cases. But what current is pointing to, current is actually deleted if this if statement is executed. So I can't set previous to current. I can set previous to previous next. That I can do. And then current is then previous next. After that, after updating previous to previous next. That's a little bit better, but previous might not exist. That's kind of the issue. Yeah, still get runtime errors here. This is still, no, this is so frustrating. This is so frustrating. Actually, that's not even the issue that I'm running into here. Yeah, current is just outright gone, deleted. But previous next points to node next. Why? Oh my goodness. Previous shouldn't update. Oh, it's like, oh, okay. Oh my goodness. That's the problem, is that, the previous value only updates if that block was it entered. Excuse me, that block wasn't entered. Excuse me, that block was not entered. Yeah. Okay. That's a pain in the neck, huh? Yep. Okay. So I can run that block on the inside multiple times. I should have another for loop, I think. And multiple times I'm gonna delete the that section, right? Yeah, each time I'm gonna update current to previous next, and keep deleting things in there until what? Until I don't enter that if statement. Then oh my goodness. Oh man, this is a lot harder than I thought it was gonna be. It's a lot more complicated than I thought it was gonna be. I thought this was gonna be super easy, this one. Wow. Oh my goodness. Let's take a moment. Yeah, so mechanically it ends up being a little more complicated than I thought. What I want to do is, because I want to delete all of those sections at once, and then I can move my previous value over, right? Because there could be multiple sections back to back to back. That's how I want to do it. Excuse me. Well, no. How would that look? Yeah, well, you just loop over current, left to right, incrementing that sum, and then once you get a sum of 0, perform the deletion routine, break, and then this will run the same thing again with current on the at the next, previous next will be current will be set to previous next, and run and just execute again another while loop, and or another for loop, I guess, and that for loop won't break until what? I think until current is a null pointer. When I try to no. I think if I don't enter that if statement, if I don't delete some section, then I break the outer loop. That's how it should work. Yeah. And then once I've broken that outer loop, then I can move my previous to previous next and current to the next value of that one. Yeah. Okay. Excuse me. Wow. Interesting. So I end up with 3 for loops? I end up with like 4 for loops. Because I have another for loop for like deleting the deleting the sequence that I just went over. Oh man, this is confusing. Yikes. Yikes. I'm not too sure exactly what I could do in the future to like make this sort of thing cleaner, faster, like coding it in just a few minutes. Aside from strict memorization, I guess I have to like think through the problem a little bit more than mechanically how the loops can operate. Maybe something like that. Maybe it's more so what I need. Linked lists are really tricky. As you can tell, they're really they can be very like the logic involved can be very tricky. Requires significant care. Excuse me. So I think using multiple for loops is the way to go. I think using multiple for loops is the way to go. So let's do it this way. Excuse me. Let's do previous next, previous, and previous next. And then we're going to set previous to previous next. All right. And then we're going to have another for loop. This node current equals previous next. While current exists, gotta do some things. And then inside of that, run this routine. Okay, so at the beginning of each iteration, I'm gonna set current to previous next. And while current exists, I'm actually not gonna set this here, right? Not gonna set this here. While current exists and there's gonna be a check. There's gonna be a Boolean loop equals true. We're gonna keep looping. And what I'm gonna do is set loop equal to false. Then I'm gonna run this routine inside. Get the prefix, start node at current, go all the way across, keep incrementing at each step. Actually, I can only keep that up. If we get 0, then loop should be set to true. Keep going, keep going. If I don't ever reach this if statement though, then I stop looping. Loop is false. And then I break this outer loop. Okay. And so here, perform this deletion. Current every time should be set to previous next. Yes. And here I take if I need to delete this section, then I'm going to break. I'm going to set the loop to true. To go to the next one, I'm going to delete this node. So I'm going to say node is current, loop starting from current. Set previous next to node next, which the node is basically the tail at this point. Well, the node is the tail. The node's going to be deleted too. So set previous to the next node there. Delete all of the nodes in between, starting from current to node, except for node. Then delete node itself. Break here. denote that I should keep looping. And then what's going to happen is this is going to set current to previous next again, keep looping as long as it's not empty. Right? If it's empty, then it won't continue either. And then it'll keep going. This is going to break when I get through all of the those sections that need to be deleted. And then finally, I'm going to end up here, where I say, okay, now now I'm going to try to find any sequences starting from the next node over. So now previous goes to previous next if it exists. And then now I look at the value to the right of that, right? Current is to the right of that, and I go through all those sequences again. So it's something like this. It's a little bit confusing, I realize. And then finally, I'm going to take the result as the previous head next. So the previous head was obviously a sentinel value that I created, a unique pointer. And so I'm going to take the result. It's going to be that new head. Set that to the null pointer. That'll get automatically deallocated, deleted. Okay, something like this. Something like this. Pretty, not the prettiest code. Not the best looking code. A little bit involved. It took me a while to really think of it. Almost an hour now I spent on this thinking about it. And I have a runtime error. Ouch. 1, 2, -3, 1, 1. All right, let's add back that debug code. Okay. I'm not sure how I got a runtime error, but yeah, there's a lot of variables involved here. There's a lot of stuff happening. This is like quadruple for loops. 1, 2, 3, 4 for loops. Yeah, that's what I was saying. Like, this is a lot. Okay. 140. So 1, 2, -3, 3, 1, 1. Okay. So what happened? So 1, 2, 3 should get -3 should get deleted. Should end up with 3, 1, 1. That's here. This 3, 1 should happen. That should be fine. 3, 1, and this doesn't fire, so loop is false. And this goes all the way to the edge. Come back here, and it should break. And then I should go to the next value, which is 1. So previous is now 1. Previous next is empty. This should break. What is previous head pointing to now? Oh, okay. This should be deleted. So I'm not sure what's going on here. Something strange is happening. I don't understand. Yeah, 0, 1 is what I expect. We have 1, 2, 3. So 0, 3. Okay, that's what it's supposed to be. Previous head next value is 3. Yes. That's what I should be returning, actually, is that exactly that. Result is previous head next. Previous head next is a no pointer. Is that the issue? What is the problem? What is going on? I don't know. I don't understand. I don't understand. Is it the thing? I don't know. I actually don't know where the runtime error is occurring. I don't know why. Is it because of the deletions that I did? I don't know. 480. So I got all the way down here. What's going on? Also, my neck is killing me. What is happening? What is happening? Still get a runtime error. 0, 3, 1. What? What? Hold on. It's not these other test cases, right? I don't understand at all what's happening. What? Use after free? Keep use after free? Huh? What is being used? Okay, well this one I understand. Actually, that I understand why that's happening. But why is this one? I'm so confused. Does the default deleter for a list node delete the entire list? Is that what's going wrong? Is that what it is? Because that would be kind of awkward. What is going on? Goodness. I think I know I don't know what's happening. I don't know. Something strange is going on here. Okay. I'm assuming that I can't run through the... What is happening? I don't know what's happening. 480, 550, 600, 650, 31. 600, 31, 650. Okay, this is perfectly fine. This... What is going on? Huh? What? I don't understand at all. Keep use after free? What's at this address? Is it the same address every time? I don't think it should be, right? 58. What is going on? What is happening? What is this? What is this? There's a way to... I want to get this as an address. Can I just dereference this number? And then, what is this? A reinterpret cast, I guess. It's something like this. I don't know if I can do that. Something like that. What is at that address? Excuse me. Surprised that compiled. It's a bad habit, huh? After 650, it just doesn't. Same address. Doesn't get that far. Okay. When does this get freed? What is that? I don't understand. I don't understand. I don't understand. 112. Okay. Maybe I should do that after, huh. Interesting. 112. 112. What is going on? What? None of these nodes have a value of 112. So I'm trying to use this address. Maybe this is the address. I don't know. Maybe that's not the address. This might be, I don't know. Maybe this is not the right address to shadow bytes around the buggy address. This might be an address of something else. I don't know. Okay. Ah, it's probably not. Probably should try to do it that way. I don't know. I'm just trying to like. I'm curious to see like what even is that? It's telling me is being Maybe I just shouldn't delete anything. Just try not to delete anything. I don't know. I don't know, man. Should be able to delete things, but nope, no, it's fine. Of course. But that doesn't make sense, right? This, I should be able to delete. Maybe the deletion is recursive. That's what I'm wondering. I'm wondering if it's recursive. The default deletion is recursive, and I don't realize that. Yeah. That could be kind of awkward. That could be a little bit awkward. It was deleted already, but how? What is going on? What is happening? What is happening? I don't understand. I don't understand. How is this possible? I think you know what it could be, which is a strange thing, weird thing, but it could be. I don't know when something is marked for deletion for deallocation. When exactly that happens, it may be the case that you could try to delete something and then you try to reference it again later and it hasn't been deleted yet by the system, so to speak. And so you get strange behavior because you get strange behavior because, oh my goodness, because you're referencing deleted memory, but it's not causing errors until later on, and you don't know when or why that error is happening. It's like hard to track where that error is coming from because temporally speaking, it doesn't necessarily happen immediately. Like if I delete here and then I try to access the node, whether or not it's been deleted, it may or may not actually cause problems. Something like that. I'm so confused. Excuse me. What's the default behavior for delete on the struct that has a pointer to itself? Does it delete the whole thing? I don't think so, right? That's like the only thing I can think of that's causing issues. I don't realize how that works. Which seems like probably shouldn't. It probably shouldn't work like that. What is it? Oh my goodness. All right, default delete. Okay. All right. Delete on pointer. All right. Let's just look at delete. Oh. Destroys objects previously allocated by the new expression and releases obtained memory area. Okay. Excuse me. Non-array object created by a new expression, an array out created by a new array expression. Okay. Null pointer to a non-array object created by a new expression, pointer to a base subobject of a non-array object created by a new expression. Pointed to type of pointer must be similar to the type of the object or of a base subobject if pointer is anything else, including if it is a pointer obtained by the array form of new expression, the behavior is undefined. Pointer must be a null pointer or pointer whose value is previously obtained by an array form of new expression whose allocation function was not a non-allocating form, i.e. overload 10. Pointed to type of pointer must be similar to the element type of the array object if pointer is anything else, including if it is a pointer obtained by the non-array form of new expression, the behavior is undefined. Okay. The result of the delete expression always has type void. If the object being deleted has incomplete class type at the point of deletion and the complete class is a non-trivial destructor or a deallocation function, the behavior is undefined. Okay. Excuse me. Which destructors are called? Excuse me. If pointer is not a null pointer and the deallocation function is not a destroy and delete, I'm not sure what that means exactly. The delete expression invokes the destructor, if any, for the object that's being destroyed or for every element of the array that's being destroyed, proceeding from the last element to the first element of the array. That's interesting. So it calls the destructor for each element of the array. Okay. After that, whether or not an exception was thrown by any destructor, the delete expression invokes the deallocation function, either operator delete or operator delete second version, unless the matching new expression was combined with another new expression. Yeah, that gets really confusing, I'm sure. The deallocation function's name is looked up in the scope of the dynamic type of the object pointed to by pointer, which means class-specific deallocation functions, if present, are found before the global ones. If ... is present in the delete expression, only the global namespace is examined by this lookup. In any case, any declarations other than of usual deallocation functions are discarded. Okay, so the destructor is called. All right, but what about the members? Lookup finds more than one deallocation function. The function to be called is selected as follows. See deallocation function for a more detailed description of these functions and their effects. Basically, like I, in the past, not but in the past, I've coded list nodes where the destructor deletes what it's pointing to, right? And so you get a sequence of deallocation. But this linked list definition doesn't include that. It's just destruct. Doesn't have a destructor for that deallocates its memory across, which is what I'm running into, the problem I'm running into here. I'm assuming excuse me. What the default destructor looks like. I think the default destructor in C++ is typically a shallow destructor, empty destructor. Whoa. Look at this. A pair of brackets following the keyword delete is always interpreted as the array form of delete expression or lambda expression with an empty capture list. Immediately after delete must be enclosed in parentheses. So this will be a parse error for this one. Oh, that's funny. For this one, okay. Interesting. You need this? Maybe you do. I guess you do. I guess you don't. I don't know. That's weird. Anyway, no, I'm wrong. No, that's not. I think maybe my code is just wrong. I'm deleting more things than I should. Maybe it's just that simple. Do I need I don't know if that really matters. It shouldn't matter. Runtime error. Why? Why? Oh, okay. Keep going here. Okay. X value 1, 2. And -3, I think. Node is what I want. Node val. Ah, gotta. There we go. Oh, feels good. Feels good. Okay. Okay. All right. Let's see. Node and node val. Yeah, I could still delete at the end. Okay. One, 2, -3, 1, 2, -3, 3, 1, 1. Z val 0, x3. Yeah, those are deallocated. Why is this happening? I don't understand at all. This is, huh? The things that are supposed to be deleted are getting deleted, as expected, right? 1, 2, -3. Those are getting deleted. I'm not seeing it. I don't know what it is. There's something strange is going on. Something I don't see is happening. Somehow I'm using after freeing that memory, but I'm obviously not using that, right? 3, 1 here. Those are the only things that get deleted, just that 1, 2, -3. I have this 0 points to 3. Right, I could verify what this is pointing to here. Do that. And then also set that to a null pointer and print the result. Like, this is kind of what I expect. I don't know. Somehow getting a heap use after free. Maybe I can't delete the head node. This got a lot of downvotes. No, it's got a lot of votes, excuse me. Never mind. Am I not supposed to delete the list? Is that what it is? I don't know. Maybe I have to set the head to a null pointer. I mean, these are. Could that be it? Do I just need? I mean, I don't know if that really shouldn't matter, but maybe that's the issue. No. I have no idea. Something bizarre is going on here. I don't know what to. I don't know. I can't identify what it is. Oh, pointers! So much fun. I generally don't have problems with pointers. I don't have a ton of practice, I'll have to say. I'd have to admit, with messing around with memory, like at this, like this, manually deleting things. It's really not something I do very much of. You're really not supposed to do that. You're just not supposed to do that generally. You should be using RAII for most of your things, which is built into like this is what unique pointers are for, and same thing for what's the other one? All the STL is like RAII, so it handles all that for you, which is great because this is obviously almost completely incomprehensible in terms of what's actually going wrong. like as far as I could tell, it's like I thought I did it right. Like it's deleting what I'm supposed to, the nodes I want to delete. It's spent quite a bit of time on this trying to figure this out. Like when I print, I'm able to literally print the lists, like all of them. Right? I mean, like unless what's being returned, like the error doesn't come until after, like around the return or after the return. Is it because I'm using a unique pointer? I don't think so. I don't think so. That wouldn't make a lot of sense. It's possible, but I don't think so though. I don't think that's the issue. I'm not going to delete it. I'm just going to leave that. Oh. Could be that. I doubt it. It doesn't seem right, but maybe. You had another get somewhere in here. Yeah, I did. Maybe I just don't understand entirely how the unique pointer works. That's possible. No, that's not the issue at all. I didn't think so. There's just something really weird going on. Something I can't seem to understand is going on here. I don't know. Yeah, some things that can be hard to understand. Not the first thing in life that I've not understood. Oh, but how long are we gonna spend? What is being used after it's been freed? What's being used? Which one? Which one is it? Okay, so I identified that it's something. I identified that it's this line. It's related to this line of code. Right? Because if I don't delete this memory, then it's fine. Doesn't make any sense to me as to why it has no problem now, but and I could delete the other ones too. So I don't know if it's, let's do if x is not equal to head. Is it just because I deleted the head? Is that why? Is that it? Because that would be really annoying. Can I just not delete that? That would be really annoying. That's why. Oh my goodness, of course. Are you kidding me? Is this some kind of sick joke? Is this some kind of sick joke? Oh my goodness. Why? Why? Why would you do that? Why? 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 Oh my god. Oh my god. I can't believe this. This is so upsetting. This is, oh my goodness. What? 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 No. Oh my goodness. Why? Why would you do this to me? No. No. It's like, what? How am I supposed to know that? How? Oh my! Is this a bug? Does this count as a bug on LeetCode's servers? I don't understand. I really don't understand that. I thought maybe it had something to do with the head. I was like, what could it possibly be? What is going on here? So I think they referenced the head node somewhere in their executing code afterwards for the result, to print the result. Part of printing the result involves referencing the head node. And if I delete the if I delete the head node, even if I return a new one, a new head node, it'll give me a runtime error. Oh my goodness, this is unbelievable. How? No. No. I think I need a break after this. You gotta be kidding me. Really? How? Why? No. Oh, I spent so much time on this too. Spent so much time trying to get it right. No. No. I don't know what to say. I don't know what to do. This is just like, you gotta be kidding me. I can't help but just keep laughing. It's just very like, you know what's funny about it is I can't tell if this is something I'm doing wrong or if it's just a bug on their server. Like how they program the error, the code that checks it. And I don't know. And both cases are funny to me because I don't know if it's a mistake I made, that would suck because that would be kind of hard to find, quite frankly. Given the code that I wrote already, it seems pretty unlikely. Oh, gotta be kidding me. You gotta be kidding me. Absolutely gotta be kidding me. This is like, how is this even possible? How? What? What? How can I make their code not do that? I can modify the memory at that address, but no, I want to I want to deallocate the address altogether. I want it to be gone. I don't want them to. No, they should not be. They should not be modifying that address. Excuse me, their print code. Definitely not. No. I deleted it. It's gone. I modified the linked list. What do you mean? What do you mean? Am I supposed to return a new linked list that doesn't have that stuff destroyed? What is going on? No, I mean, no. Right? I mean, hello? It says delete. It says remove. It says, what? Oh my goodness. Huh. I don't know, man. I don't know what to say here. This is like, you gotta be kidding me. I mean, I could just leave the memory there. It's kind of a memory leak, quite frankly. But it's like, how am I supposed to work around this? How am I supposed to do this? What do you mean? What do you mean it references the head memory after it's been potentially deleted? What? Why would you do that? Why would you do that? Why would you do that? Aren't you supposed to delete the memory of an object when you're done with it, when it's gone? Isn't that just a memory leak if it's... I know I've written code in the past where I didn't bother, but like technically you're not supposed to do that. You're supposed to... Oh, this is brutal. This is a rough one. This is like, here I am trying to solve these in 5 to 10 minutes each, and here I am just taking like hours, pulling my hair out, trying to figure out why I'm getting a heap after free. When clearly it's happening, that's clearly happening after my code returns. And so it must be that I modified some memory that they're accessing in their on the back end. Excuse me. Oh. Yeah, when their server is running this code, it oh my goodness. I can't believe this. When their server is running this code, I'm assuming it doesn't run in the browser. I don't think so. I don't think the browser does that. Assuming it's running on their server and being sent back the result. Oh man. I don't know what to say. I'm really like, okay, well, shoot. Of course. Yeah, I mean, in the past, though, like I wouldn't bother to, free the memory or whatever because it's like, well, it doesn't really matter. But realistically, you probably should have functions that do, like if you're dealing with linked lists, particularly because you can't, what do you call that? You can't really access those elements if it's in a linked list outside of the linked list itself, or a single linked list, unless you have another data structure that's keeping track of the memory too. But that's kind of like a little redundant. Yeah, I don't know. I've kind of run into that. I've run into that problem before with LeetCode questions where I'm like, I'm not really sure what level of memory management I should be handling here. Like with things like vectors and other data structures, it's RAII, so you don't have to think about any of that. But when you're dealing with like custom data structures that have that are kind of like expansive data, I don't know, not expansive data structures that have pointers to other other objects like trees or linked lists, or even graphs in some cases. Or not really graphs so much, but yeah, linked lists and trees. Like, should I be doing any kind of memory management on those objects? Is a question I've had to ask myself, especially when you're like deleting parts of the. I usually just leave that out because it's not really the algorithmic part, but it is relevant because you do actually need to handle that in real scenarios if you're actually doing memory allocation and whatnot. And yeah, it's good practice, number one. Number two, it is like a real thing. But it's also kind of hilarious that like apparently the questions themselves are not written in such a way where if you do memory management, if you do the memory management, it's not going to work. Or how exactly should you manage the memory is like a question. Yeah, I don't really know. I don't know what to say here. I don't know, man. I don't know. I don't know. Well, gee. Okay. That's awkward. You know? All right. I definitely want to take a break after this. I don't even know what to make of this. It's like, okay. Okay. It struck me that C++ is pretty tough as a language, isn't it? It's kind of tough. just dawned on me. Like it's really good. I think it's what really everyone should know. Quite frankly, you really should. I feel like everything should be just C++. But Definitely challenging, huh? Especially dealing with memory management. So yeah, that's gonna just go ahead and not delete the head. Easy. That's all I had to do. Just don't delete the head. Well, that was rough. That was rough. Like, yeah, I'll spend a few hours, do 10 minutes a question, get through a bunch of questions. No, that's not how this is gonna work. Not how this is gonna work. Sorry, bud. Not today. Not today. I think I got it. Let me remove my debug code and same thing. I have to guard the head at every point. Remove all this debug code. Oh my goodness. Absolutely ridiculous. Unbelievable. I cannot express. Cannot fully express how disappointed. Not just disappointed, but yeah, disappointed. Well, annoyed. Disappointed, annoyed, some variation of those things. It's just like, like really? Really? Yes. The answer is yes. You asked, really? The answer is yes. Alright, I'm gonna write a script to generate some test cases. 1,000 nodes between -1 and 1,000, okay. Oh man. Oh, quick script to generate some test cases. G. Oh man. Programming's kind of tough. Programming is definitely tough, I have to say. Programming in C++ is tough. Okay, you don't have this problem in other languages. You literally don't have this problem in almost all the other languages. It's probably why they created the other languages. People just can't handle it. They're like, it's too much. Memory management's too difficult. Nobody can get it right. I guess technically they didn't get it right on their server. Like, that's basically what that means. That implies to me. I think that's what that means. Of course. All right. So K and C and N. We're gonna say K is gonna be between 1 and 1,000. So int N is gonna be int 1 plus K times rand. Yeah, it could be 1,000. Let's do like 100. It's probably a little bit better for now. That'll be how many nodes. C is gonna be between. We'll do like size 20 is the range. C1 and C2. Let's do -10. -10 to +10. Go back to that. What that's going to be used for. And then have a for loop. And then print, call it x. Do I is 0, I is less than n. Increment I. Okay. And it's going to be x. It's empty string. If I is greater than 0, then x gets a comma before we put. We're gonna do x. We're gonna put a value to the right, and then put a comma before the x on the left side of x. A little bit confusing how this works. The comma goes to the right, but we put the comma there before we put the number. This is just gonna be an int. C2 plus C1 times rand. Yeah, something like this. And then just go ahead and add this, opening and closing brackets. And I can just do for j in sequence 1 to 8. Do, done. Okay, very good. So let's keep it kind of small initially. All right. Oh, just make sure I didn't do anything kind of silly. Do a few of these. Let's do like maybe, let's make the range really tight. So that way, let's do like 4 and -2 to 2, right? So -2 plus random number from 0 to 3. Let's do 0 to 5 or 0 to 4, yeah. So it could be -2 or 2, -2 up to 2. And then let's do 100 of them. That's fine. 8 times 100, 8 times. Then we have a whole lot of things that are add to 0. So I get a lot of sort of things happening here. Let's run that like 3 or 4. Let's do 3 of them. 1, 2. And we'll do a third one. I think I want, I also want to test, like if it's an empty list. No, it can't be empty. It's one element will do. I think I already did that actually. I don't know, didn't do that. Do one element. Definitely should have a test case of one element. And then I'm going to do a round of regular values from -1,000 to 1,000, 2,000. Yeah. Oh no. Okay. Let's try again. Maybe we'll do one more, just for good measure. I'm afraid this is wrong. I don't know why. I don't know why it's wrong. I'm afraid that it's not wrong, and I don't know why. Afraid to submit it. It's just, I don't know, man. It took me a while to do this. That's kind of the issue. Usually when something takes a while, I'm like concerned that maybe there's something wrong. Okay, got it. Oh. Oh, that was rough. That was a rough one. I'm definitely taking a break after this. I think I've had enough for a little while. Yeah. All right. Submit that 4 more times, and then move on to the next thing. 1, 2, 3, 4, 5, 6. So yeah, if you like this sort of thing, give the video a like and subscribe for more. And I'm going to go ahead and yeah, the speed is not great. I mean, it's quadratic time. Maybe you could do this in linear time, but I didn't really take the time to think of a linear time solution. I just figured a quadratic time solution should be sufficient. I can move on from there. It's still faster than most solutions, a lot of solutions anyway. Most of the solutions actually. But obviously, yeah, quadratic is not great. There may be a better way to do this, but I was hung up on just getting it to work at all. Like I said, I'm like trying to do these things quickly, but I guess if I want to do it quickly, I probably should not be messing around with the memory management, quite frankly. Oh, there we go. We got 99% anyway. Yeah, it's kind of typical. It's kind of typical that, like, if you only have 1,000 elements, even doing it in quadratic time is still probably pretty efficient. Actually, this particular approach is general. I think you would expect it to be linear time anyway. It's not worst case linear time, but it's I think the expected case would be linear time, and the reason is that if you have those prefix sums that are size 0, like, well, they said any what do you call that? Any solution is accepted that has that. Actually, never mind. What am I saying? Never mind. I don't think it's expected linear time either. I don't know. I think it's just fast enough in this case. It's just, for some reason, it's faster. I don't know. Fast enough, I guess. It's not expected time linear. It's not true at all. It's worst case quadratic, and then I don't think it's expected time linear. No, I don't think that's true. Anyway, thank you for watching. I'll talk to you soon. Have a good rest of your day. Take care. Take care. I don't know if I'm coming back to another question. I think I'm probably just gonna take a break. I may or may not do another one. That took a while. It took a lot of time. All right. Take care.